Calculus Scholars, welcome to part 2 of section 4.6, where we are actually going to be doing our U-Substitution right now. And we will show you how this works. So anyways, I have a checklist up here on top, and we will kind of demonstrate how we do this U-Substitution right now with this first example. So the first thing that we want to do is we want to find our U. So when we do that, the U is usually obviously something that's kind of in parentheses or in radicals first. So that's what we kind of look at first. So I'm going to kind of highlight what I think my U is in blue. So my U is going to be 3x minus 4. And then our du is going to be 3, and we actually include a dx to kind of signify that that is our derivative of sorts. So we always put a dx after we do the du. Now our goal here is that we want to get dx by itself. So I'm just going to circle that we have this dx. So I want to get that by itself. So what I'm going to do is I'm going to divide by 3. So that's du over 3 equals to dx. Now, I like calling this a little bit better, 1/3 du. That's equal to dx. So now, the next step, so I've found my du, I've solved for the dx, so my next step is to turn this into a new and improved u integral. So what I'm going to do here is I'm going to set up a new integral, and I'm going to call this the integral of u to the 5th and then the dx is equal to 1/3 du. And actually, just to kind of show you directly where this is coming from, I'm just going to kind of go through this in red. So this is the 1/3 du. And to clean this up a little bit, I'm going to put this 1/3 outside. And I have the integral of u to the 5th du. So now I have an integral that is pretty basic to do. So this integral of u to the 5th du is a very simple power rule type of integral. So when I kind of do this and complete this, I get u to the 6th times 1/6. And technically speaking, there is a plus c that is going on with this. And we're just going to multiply now. A 1/3 times the 1/6 gets me to 1/18 u to the 6th plus c. And I'm going to put in my u. So my u was 3x minus 4. Plus c. And then we are all done. So we have successfully done our first U-Substitution integral. Okay, next we are going to go to an integral that kind of, well, let's see, we got something to the fifth power. Then we have a 3x squared on the outside of that. So you may be wondering, how do we choose our u? Now, usually you could tell what your u is when it's kind of in parentheses and kind of, grouped in on its own. So like this x cubed plus 4, is a pretty good candidate for my u. And there's going to be something really cool that's going to happen with this one. So I go to u, and that is equal to x cubed plus 4. And then our du is 3x squared dx. Now this is really, really nice because we have a 3x squared dx already that's on the outside. So when I rewrite the integral here, I'm actually going to have the integral of u to the fifth, and I'm going to have, I already have a 3x squared dx, and that's my du. Now, if you wanted to solve for dx, and you wanted to see what that comes out to, we would get that our du over 3x squared is equal to dx. And you would kind of see that the 3x squared in the denominator with the 3x squared that's kind of being multiplied would cancel out. So I think it's actually simpler to kind of make the observation that the 3x squared dx is the same thing as your du. And then now we could kind of integrate this thing. So when we integrate this u to the fifth du, I get u to the sixth times 1/6 plus c. And I get 1/6 times x squared, x cubed plus 4 to the 6th power plus c. So something that looked like it was going to be, maybe a reverse product rule, something like that, really didn't turn out to be all that bad. And this gets us a completely integrated integral with the U-substitution. Of course, U-substitution also works in those ugly type of radical cases. So let's look at this one. Now this one, I think the U is kind of obvious here. So the U, pretty obviously to me, looks like that 4x minus 5. So you don't ever want to include the square root with the u. You look at what's inside of the square root, because the square root is kind of like a grouping symbol. So then we do the du, and that is just 4 dx. And if we want to get dx by itself, you just divide by 4. So I like to call this just 1/4 du equals to dx. Now, if I'm integrating this thing, what I would do is I would write this as the integral of square root of u first. And make sure that you include the 1/4 as well. And to kind of clean this up, I put the 1/4 out of the integral symbol, and then I call this u to the half du. And then after that, I'm going to add 1 to the exponent. So 1/2 plus 1 is 3/2. And then make sure that you also include the plus c. Now I just like to kind of, there's always going to be a plus c at the end. And then we could just multiply the fraction, so I get 2 over 12. If we want to, we can kind of clean this up and call this 1/6 instead. And then I got u to the 3/2 plus c. And we're going to put in the 4x minus 5. And if you have this as your final answer, you know, this is pretty convincing to me that you kind of have understood your integration with the U-Substitution pretty well. We're going to do one more on this page in the next video. It will kind of get its own video, and it's kind of a more difficult one that kind of deserves its own attention. And it would be kind of the level that we would see on maybe those harder homework problems and test questions. So please tune in for that.